Hi to all. Today's topic is induced EMF across a rod of length L is rotating in uniform magnetic field of induction B. This is a rod. Okay, look at here. Its length is L. This rod is rotating in the magnetic field with certain angular velocity omega. In the uniform magnetic field, this is the magnetic field. This magnetic field is inward cross. The rod is rotating in the uniform magnetic field. Then I am going to derive the formula for induced EMF across the rod which is rotating about its one end. Okay, look at here. Here L is the length of the rod, omega is the angular velocity, and angular velocity formula is already angular displacement by time. For example, angular displacement in n rotation, in one rotation angular displacement is 2 pi 360 degree, that is equal to 2 pi radians. In n rotations angular displacement, angular velocity equal to angular displacement by time. Angular displacement is in n rotations 2 pi n. Time taken for n rotations is t, 2 pi n by t. Or otherwise we can also write that number of rotations by unit time n by t we can write as frequency, 2 pi nu. Nu is the frequency, t is the time for n rotations. Time for n rotations, right? What is t? Time for n rotations. Look here, this is the time for n rotations. Time for n rotations, right? Okay. Now here what happening? The rod is rotating about one end. Rod is rotating about its one end. Okay, I want to derive the induced EMF across the rod. Then for that, what happening? I want to derive the induced EMF across small element of length L, right? Length dr I am taking. Okay, look at here. This dr is the small element length. This is the full length of rod is L, and in this small part I am taking, that length is dr. Okay, right. Then here induced EMF formula, we know that if, for example, this is a straight conductor. If it moves in the magnetic field, right? Okay, look at here, this is the magnetic field. It's a conductor, right? And it is moving, its length is L, it is moving with velocity v, right? The magnetic field is B. In this case, what happening? Length and velocity field, they are perpendicular to each other. Length and velocity and field. And velocity of every point is same direction and with the same speed it is going. At that moment, the induced EMF across the rod is BLV. But when you take the rotation, in this rotation, okay, velocity formula in the rotation of rod, if you take the different points, they are not having the same velocity. They have v1, v2, v3, v4, because v is equal to r omega, v proportional to r. That means the linear velocity of the rod which is rotating is different at different points. Okay, that's why here we cannot use the direct formula for induced EMF as BLV in the rotating, because the V is not constant. In this case, if it goes in straight line, then we can take as induced EMF as BLV. But in this case, what happens? First we have to take a small element on the rod, right? For that small element, the velocity is almost constant. Then we can take as the induced EMF across the small element as BLV we can use. Induced EMF formula BLV we can use. But the induced EMF is D is for the small induced EMF across the small length. Across this small length, almost velocity constant. But if you take completely other point, then the velocity is different. For the small points, then we write as BLV. L is dr into V we can write. Okay, this is the V is the velocity of that dr part. Okay, linear velocity. And if you want the total induced EMF across the rod, if you want the total induced EMF, right, we have to integrate. Why we have to integrate? What is the need? Directly why we cannot write BLV? Because V is variable. Whenever the variable is there, then we have to go for the integration. Then integration E is equal to, we will get integration D, right, and that is integration B dr into V. Here integration, in place of V we can write as R omega, then we write as B into R omega dr, because we know already relation between the linear velocity and angular velocity, that is V is equal to R omega. Then we have to write the limit set here from where to where we are integrating, right? Where to where we are integrating. We are integrating the minimum length, dr is a small length, and r is its distance, r is the radius. The r value, the minimum value is 0 and the maximum, r is what? Small element length from center, right? That is r. The small element length is dr. This is the small element. This is small element distance is r. Okay, right. Then we write here induced EMF as B omega into integration r dr. But we have to write the limit set here. R value, r lowest value, r is the radius. The radius lowest value is 0, highest value is L. We write the integration from 0 to L, 0 to L, right? And here in E is equal to B omega into integration R dr is what? R square by 2, you know already. This from where you will get integration x power n dx formula. That is, you know, integration x power n dx is, right, what is it? X power n plus 1 by n plus 1. This formula we have to use it here. Then integration r dr is r square by 2. Then according to that, here we have to substitute the limits. That is, induced EMF is equal, we will get as B omega into, in place of r we have to write upper limit first, L square by 2 minus, in place of r 0, lower limit we can substitute. That is, the lower limit is 0, then 0 square by 2. Then finally you will get some formula, that is B omega into L square by 2. The final induced EMF formula is half, we write half outside, B L square omega. This is the induced EMF across the rod. Induced EMF across the rod. What is the formula? When a rod rotating with rod of length L, it is rotating with angular velocity omega in the magnetic field of induction B, then induced EMF formula is 1 by 2 B L square omega, right? This is very important derivation, and you take the screenshot and note every point. If you have any doubt, you can ask. It is a previous CBSE question also, that is the derivation. It's an example problem also. In the example problem also they gave the same thing, right? Okay. And okay, completed? Okay, I'm going to rub it. Then after this, first I am going to give the already we derived the induced EMF formula at here. I want to know which is positive terminal and which is negative terminal. EMF generates it here. Then in the EMF, what is positive terminal and what is negative terminal? This will, across this induced EMF EMF develops, EMF induces. That induced EMF, right, across this induced EMF produces, EMF produces, this will act as a cell. That means one side will act as positive and other side will act as negative. Then which is act as positive and which is act as negative? You see here you have to use the Fleming right hand rule to know the direction of the induced current. Then further what you have to do, just you have to stretch the forefinger, central finger, thumb mutually perpendicular to each other. After that, adjust the forefinger in the direction of the field and thumb in the direction of the motion of conductor. Then the central finger indicates the direction of induced current. First forefinger in the direction of the field inward, red cross mark, and velocity, motion of conductor like this, velocity V, and then current is inward. That means current goes from P to O. Induced current flows from P to O. Actually this, when it will act as a cell, right, the current flows from P to O, then in the cell, you know that current flows from negative terminal to positive terminal. Outside of the cell it goes from positive to negative, but inside the cell it goes from negative to positive. Here we are getting the current towards O, P to O. That means here this is negative and this is positive. Then here we will get that is O is positive. O act as positive. That means at high potential, and P will act as P act as negative, okay, negative potential, and this is at a low potential. Negative is the low potential, right? Okay, low potential, high potential and low potential. This is about induced EMF and complete information. And next topic I am going to start, that is, if the rod, here the rod is rotating about one end, then if the rod is rotate about its center, then what is the induced EMF across both ends, right? And that I am going to do. I am going to rub completely, then after that again I will start. I am going to press the pause button, right? Okay, look at here, this is our next topic, that is induced EMF across a rod of length L rotating about its midpoint in the uniform magnetic field of induction B. Just like similar to that previous one, but in the previous one the rod is rotating about one end, like this it is rotating, right? But now the rod is rotating about the midpoint like this, right? This is rotating about midpoint. Rotating about one end means like this. Rotating about one end is already completed, and now I want to derive the induced EMF across this. First, we already, this part we know already, if this part rotates with certain velocity and with angular velocity omega, this part only we assume this part, and across this some EMF induces, already we derived that one. Then here we write induced EMF across O and P, right? Induced EMF across O and P. What is that formula? Half B L square V omega we can use. Previously just we derived, but its length is not L, its length is L by 2. Then the total length of the rod is L, but here we want the half of the length. The half of the length from O to P length is L by 2. That's why we write as B L square omega, that is L is L by 2 omega. Then here we will get induced EMF, that is 1 by 2 B L square by 4 into omega. Then here we will get induced EMF across this 1 by 8 B L square omega we will get. This is equation 1. But the induced EMF is equal to potential difference across this. For example, the potential at O is VO, and the potential at P is VP, and the potential at Q is VQ. Then induced EMF between O and P is equal to potential difference, VO minus VP, because O is at high potential and P is at low potential. Then we write 1 by 8 BL square omega. Okay, right, this is equation 2. Then similarly we can write the induced EMF. Similarly induced EMF across O and Q, that is across O and Q, that is also same, right? OQ length is L by 2, okay, L by 2. Then we write as here half into B L square omega, L is L by 2 square omega. If you simplify this, we will get again 1 by 8 BL square omega. And here this is nothing but induced EMF across OQ is nothing but potential difference, VO minus VQ, that is 1 by 8 BL square omega. This is equation 3, right? I want the EMF across PQ, potential difference across PQ, okay? Then just you have to add the equation 2 and the equation 3. We will get one thing, that VO minus VP plus VO minus, what we can subtract them, instead of adding we can subtract, what you will get, okay? we can subtract I want to find out the Vp minus Vq, okay, or Vq minus Vp, whatever it may be, okay. For that we can go for the equation 3 minus equation 2, okay, we can do, and that is Vo minus Vq minus, you have to do the left side minus, we can do minus Vo plus Vp, right side 1 by 8 Bl square omega, and for the equation 2 also 1 by 8 Bl square omega, right, this will cancel, then Vo and Vo will cancel, these two also cancel, finally we will get Vp minus Vq is equal to 0, we will get this potential difference between the P and Q, right, okay, then EMF across PQ is also 0, that means there is no EMF across PQ, because here this is act as positive potential and this is the negative and this is the negative, right. This VQ potential at P equal to potential at Q, that's why there is no potential difference across P and Q. Vp is potential at point P, potential at point P, okay. VQ is potential at point Q, and VPQ or Vo is the potential at O, potential at O, okay, right. Then here we derived some equivalent diagram to understand clearly, that is equivalent diagram. We know that if this is as one rod, its length is L by 2, it is rotating like this, then O is act as high potential, P is act as low potential, OP will act as one cell, right, that we write here, this is the O and this is the P, okay, this will act as one cell, its EMF is what, EOP, right, and this is the positive and this is the negative, and the next we draw like this, this is O and this is positive, O will act as positive, right, and this is plus and this is minus and this point is P, okay, this will act as one cell, across that EMF is EOP, right, we know already, and this side this part also act as cell, across that EMF induces, that is EMF across OQ, that is equal to 1 by 8 Bl square omega, then that is this point we can consider as Q, and O will act as positive and Q will act as negative. You know that already, center point is high potential, other one low potential, this is positive, this is negative. And now there are two cells are there at here, one is EOP and other one is EOQ, both are having same EMF, but these are wrongly connected in series, then the net EMF according to that net EMF, right, what you will get, that is EMF across PQ is equal, we write here, we have to subtract them, EOQ minus EOP, because in the right connection of cells we write in the series combination E equal to E1 plus E2, but this is the wrong connection because plus should be connected to minus, wrong connection, we have to subtract them, EOQ minus EOP, but EOQ 1 by 8 Bl square omega, EOP 1 by 8 Bl square omega, then induced EMF across PQ we will get as 0. This is in another format from equivalent diagram also. In any way there is no induced EMF across PQ, right, this is induced EMF across a rod of length L rotating about its midpoint. There is no induced EMF across the both ends of the rod, but there is some induced EMF across center and edge of the rod, center and other edge of the rod also, right, and take a screenshot and note it every point, and if you will get any doubt you can ask me. Okay, let us see here one important note point I am going to give. A wheel has n spokes each of length L rotating with angular velocity omega, then induced EMF across the center and rim of the wheel I want. For example, this is a wheel, it has n spokes. Look here, there it has n spokes. Each spoke has the length, this is center axle and the length is L, and this wheel is rotating with angular velocity omega. Okay, it is rotating with angular velocity omega, and this is the center and this is a rim of the wheel. This is the rim, okay, rim, and this is the wheel. It has n spokes. Then my question is that, right, what is the induced EMF across the center and rim of the wheel? Look at here, when you see here, each rod or spoke will act as one cell, right? Then EMF across each spoke what? Okay, induced EMF across each spoke. What is that? Yes, can you give? Right, that is induced EMF across each spoke is half BL square omega. Right, that means each spoke act as one cell, right? And then the O is at high potential, O is positive, and the rim, okay, right, center will act as positive and the rim will act as negative, right? The center of the wheel is positive at high potential, center of wheel at high potential, okay, center of wheel at high potential, and rim is at low potential, okay, rim of wheel at low potential, right, and that is negative, okay, high potential means positive, this is low potential means negative, right? Then each spoke will act as one cell, and across the cell, okay, across the each spoke the induced EMF is half BL square omega. This is positive and this is negative. Then this will act as one cell, okay, this is act as one cell with positive towards O and negative towards rim. Like this, these are all act as cells, and then for every cell the positive is towards the center, okay, and the negative is towards the rim, and like this there are number of cells, each of EMF E, right, each of EMF E. Then how they are connected? Then when you see this, then you see here all the positives are connected to center and all the negatives are connected to the rim. That means all the cells, right, these n cells are n spokes act as n cells, right, n spokes are the n cells. When they are connected in the parallel, right, then effective EMF equal to EMF of one cell only, right? N spokes means each spoke act as one cell, n cells are connected in parallel, right, in parallel. Then effective EMF across center and rim of wheel, right, center and rim of wheel, that is effective EMF equal to EMF of only one cell, right, in the parallel combination. When n identical cells each of EMF E are connected in parallel, then their effective EMF equal to E only. That means what we can write here? We can write one thing, that this induced EMF, if one spoke is there, that how much EMF generates. If n spokes are there, then also it will generate the same EMF. That means induced EMF is independent of number of spokes. independent of number of spokes. Number of spokes. This is our note point. This is the important point. Based on that, the problem is very important. Okay, right. Note it and take the screenshot, and I will explain the problem. Okay, let us discuss one problem. It's very important. It's a CBSE problem. There are a wheel has 10 metallic spokes. The number of spokes. This is the number of spokes. A wheel has this many spokes. Each spoke length is 0.5 meters. The length of each spoke is 0.5 meters. He is rotated with a speed that is 120 revolutions per minute, right? The number of rotations per unit time they give, that is 120 revolutions per minute. Okay, this is also, we can tell frequency, no problem, right? And then number of rotations per unit time is called as the frequency. Revolutions, we write as 120 revolutions per minute. Minute converted to seconds, right? That is the 2 revolutions per second. 2 revolutions per second. It's a frequency, number of revolutions per second. And then this wheel is rotating in the horizontal magnetic field, earth magnetic field. That earth magnetic field they give as 0.4 Gauss, converting to Tesla. That is 0.4 into 10 to the power of minus, what is 1 Gauss equal to 10 power minus 4 Tesla, right? 1 Gauss is equal to 10 power minus 4 Tesla. And next I want, what do I want? Induced EMF I want, right? You know induced EMF formula, right? That is independent of number of spokes. That is induced EMF formula is half BL square omega. Half BL square omega. But what is omega in this? We want to find out the omega here. Let us go for the omega. Omega is equal to, that is 2 pi n by t. That is nothing but 2 pi nu, right? 2 pi into nu value is, you know, here, right? Or n by, that is 2. Then we will get the 4 pi radian per second. Okay. Angular velocity equal to angular displacement by time. Radian by second. Here we substitute all values. Induced EMF is equal to half B. B is what? BH we have to take. What is BH? 0.4 into 10 to the power of minus 4 into L square. L is the length, 0.5 whole square, right? Into omega. Omega is 4 pi, right? We have to simplify it. Then this is, it was very easy. That is the 1 by 2 into 0.4 into the power of minus 4. This 0.5 is nothing but 1 by 2. We write 1 by 4 into 4 pi. We write this 4 will gets cancelled. This is 2 into 0.2. Then E is equal, we will get as 0.2 pi into 10 to the power of minus 4. We can also write as 2 pi into 10 to the power of minus 5. Where pi value you know, that is 3.14. 2 into 3.14 is 6.28 into 10 to the power of minus 5 volt. This is the small amount of voltage that develops across the center and rim of the wheel. Okay, right. This is the solution. Thank you for watching my lecture. Till now, if you not subscribe my channel, subscribe and share to your friends.